Hi everyone, here's the second part of our homework from chapter 16. So we are still doing the kinetics, okay? So the second part, first question. Sucrose decomposes to fructose, okay? And when ln sucrose is plotted versus time, straight line with slope of this value is given. What is the rate law for the reaction? Now, how do we answer a question like this? We have to refer to the plots. Now, what information we have here is, you guys can see that it says the graph was plotted again ln sucrose versus time. And also we are given the rate constant, which is the slope, negative 208 per hour. So with these two information we can find out what is the order of the reaction, and with respect to that order what is the slope going to be. So we can refer to our plots over here. Okay, remember we talk about in our lectures that you can draw graphs based on either concentration versus temperature, not the temperature time, or the ln concentration versus time, or the 1 over concentration versus time. Okay. So here, if it is a zero order reaction, it's going to be concentration of A versus time. For first order, ln concentration versus time, and second order 1 over concentration versus time. Okay, and also we know the units. Now in this particular question, the graph was plotted again ln sucrose concentration versus time and gotten a straight line with a negative slope. So that tells us that is a first order reaction that they are talking about. And in addition to that, another piece of information that we can find is, now remember we talk about the units. Okay, so where did we talk about the units? For not this one, over here. You see here in this slide we talk about reaction order and the units for K. So you can see here, if it is a zero order reaction, these are the units, moles per liters per second. If it is a first order, 1 over S, 1 per second. So seconds could be per minutes or hours. Still, if it is 1 over time units, that's a first order rate constant. If it is liters per moles per second, that is a second order rate constant. So from these units also we can identify whether a reaction is zero order, first order or second order. Okay, so with that in mind, we can go back to our question. So here it talks about that it is slope is negative 208 per hour, and then graph was plotted ln sucrose versus time. So with that two information, we know that this talk about a first order reaction. So in that case, what is the rate law for the reaction? So the rate law then has to be rate, and then the slope gives us the rate constant, that is 0.208 per hour. And then for a first order rate constant, sucrose is our reactant, sucrose, and it is first order, so just sucrose like that. Okay, so 0.208 per hour sucrose going to be your answer for this question. If it is second order, then you have to put 2 right there. If we were given the second order units for the rate constant, as well as the graph is drawn to get a straight line based on the second order parameters. Okay, so this is the first order, so because of that the rate is going to be something like that. That is the answer for that one. And number 2, now tetrafluoroethylene C2F4. Okay, some information given. A plot of 1 over C2F4 versus times gives a straight line with a slope of 0.0448 liters moles per second. Now in here, in this question also, we do have some information. It is, the plot is drawn 1 over C2F4 versus time, and the slope is given this, a positive slope with this particular units. Now you look up the units and type of graph, 1 over concentration. So let's go back here, and then liters per moles per second over here. So these are the units that was given. So that tells us reaction is second order. And if you refer to our plots, let's go back here. Different types of plots. The summary, where is it? I think I missed it. Over here. You see, slideshow from the current. Okay, so this one, the graph was drawn 1 over concentration versus time. Oops, not this one. Okay, over here. Okay, so over here, 1 over concentration versus time gives us positive slope. Okay, you see here the units for K, liters per moles per second, and graph of 1 over concentration versus time given a straight line, meaning that is a second order reaction. So with that in mind, we can go ahead and answer this question. Now we want to write down what is the rate law for this reaction, and the reactant is C2F4. So then the rate is going to be rate constant 0.0448 liters moles per second, and C2F4, since it's a second order reaction, you have to write it like that. So that's going to be the answer. Okay, so you choose the correct one. And number 3, a reaction is first order with respect to the reactant R. Which of the following plots will produce a straight line? It says it's a first order reaction. Okay, reaction is first order with respect to R. Which of the following plots will produce a straight line? So again, you refer to the this table over here. Okay, so it says it's a first order reaction. So then you can see how do you get a plot for straight line. Okay, Ln concentration versus time. Ln concentration of your reactant versus time would give you a straight line if it is a first order. If it is a zero order, concentration of A versus time, and if it is a second order, concentration 1 over A concentration versus time. So with that information, you should be able to understand and answer this question. Okay, which one produces a straight line? Okay, so you can find the answer right there. I see it. Number 4, a reaction is second order with respect to the reactant R. Which of the following plots will produce a straight line? Again, so second order, it's going to be, again you can refer to this table. For a second order, what is the plot for straight line? There is going to be 1 over concentration of A versus time. So which one going to be the correct answer? There would be 1 over concentration. Right? 1 over concentration of R versus time. That would be the straight line for a second order reaction. And then number 5. The decomposition of hydrogen peroxide is a first order reaction. So we are given some information that would be beneficial. It says it's a first order process with a rate constant, this one. And remember the units for the rate constant per second, which is similar to per minutes if it is given in minutes. How long will it take for the concentration of H2O to drop from 0.02 to 0.012? Now in this question it involves two concentrations. So what we have to do is we have to refer to the integrated rate equation. Okay, so you go back to your PowerPoint slides and we can find out the integrated rate law in straight line form. You can use it over here too, or you can refer to this one. Which one I like? Integrated rate laws over here. ln A naught over ln A naught over AT equals KT. Okay, so we can consider over here ln A naught over AT equals KT. Okay, so this one we can use for the integrated rate law from this slide. Excuse me. Okay, so with that in mind, ln A naught over AT, you go over here, question ln concentration of AT, or A naught over AT equals KT. So because this one we have two different concentrations at 0 time and at a certain time. This is for this one. Okay. Okay. So how are we going to use this information? So concentration at the beginning is this A naught. And this is going to be your AT. So ln concentration at the beginning is 0.02 and concentration at a certain time 0.012. ln equals rate constant given 1.06 into 10 to the negative 3 per minute. Per minute times T. T is what we are going to find out. So ln 02 over 0.0120, that would be ln 1.66. Okay, ln 1.66, when you find ln 1.66, that would be 0.506. 0.506 over 1.06 into 10 to the negative 3 equals the time. Over 1.06 negative 3. Yes. So you will get a number that would be closest to one of the answers. So you can get the correct answer. Okay. 0.02 over 0.012 and you get ln of that 0.510. I got 0.510 here. Okay, 0.510 ln 02 over 012. So you find T and you can find out the time. You will get the answer from one of these after you do your calculation. Okay, I'm going to leave it up to you to get the final answer. And I'm going to go ahead and erase this part. Let's see number 6. So number 6, cyclopropane is converted to propene in a first order process. It also says it's a first order process. Rate constant is given. If the initial concentration of cyclopropane is 0.150, what will be the concentration after 22 hours? So here again, what you're going to be using the same equation because it's a first order reaction. So you use the equation that relates with the time which is the integrated rate law. So you use the same equation since it's a first order reaction. So ln A naught is going to be 0.150, okay, over AT. That is what you need to find out. Equals rate constant is given 5.4 into 10 to the negative 2 per hour times the time. So time is 22 hours. 22 hours. So hours to hours cancel. So you're going to multiply 5.4 into 10 to the negative 2 with 22. Okay, and then here we have ln on our left side. So if you get the anti-log of both sides, there would be 0.150 AT, and then you take the anti-log of the other side, there would be E. You multiply these two together, that would give you a number something like 5. Let's do that. Go ahead and do the calculation with me. I might do something wrong, but if you catch that I am doing something wrong, please let me know in an email so I can correct. 1.188, yeah, 1.188. When you multiply these two, 1.188, and I take the anti-log so that I can get rid of ln from here. So exponent 1.188, anti-log of that 3.28. Okay, so 3.28. So the concentration of A going to be 0.150 over 3.28. Yeah, I got an answer. Yes. Which question are we on? We are on question number 6. Okay, I was looking at the answers. We were talking about number 6. Okay, so you guys can find the answer for number 6. Okay, that's how you do it. So you do the final calculations and you can get the answer. I'm gonna go ahead and erase. So number 7 again. A gas phase decomposition is first order with respect to reactant R. If the initial concentration of R given and then the rate constant given, what concentration of R remains after 25 days? Which is also similar to what we just now did. And for this question also, we're going to use the same equation, integrated rate law, for the first order reaction. Okay. Same equation. This one over here, ln A naught over AT equals KT. And concentration is given, initial concentration is given, initial concentration, this one, right? And moles per liters. Rate constant, this, per second. So that tells us it's a first order reaction. So for the first order reaction, integrated rate law is this. Since it's asking what concentration of R remains after 25 days, two different concentrations, so we have to use the integrated rate law. So again, ln A naught is going to be 1.0 into 10 to the negative 4. And we don't know AT, meaning concentration at a certain time. K is 1.08 into 10 to the negative 6 per seconds times 25 days. So now this is given in per second and 25 days. Now here what you need to do is you need to convert days to seconds to have the same units. Okay. Okay. So I'm going to write here 1.08 into 10 to the negative 6 per second and converting it to times 25 days. 25 days, and now you need to convert it to seconds. So 1 day is 24 hours and 1 hour is 60 minutes times 60 seconds. 60 times 60. So you multiply all these things. Okay. So when you multiply all that, you will get something like this, 2.3328. Okay. That is going to be ln 1.0 into 10 to the negative 4 over a t. Now what are you going to do now? Remember the procedure we did earlier? To get rid of the ln from the left side, you take the anti-log. Okay, so that will make this part, I'm going to write that part here, 1.0 into 10 to the negative 4 over at. So anti-log would be e 2.3328. So you take the ln, anti-ln e 2.3328. You take that number and then you can solve for concentration of A. Okay. That would be the answer for 7. Yes, I got an answer. Yes, so I have the answer over here. So you do the calculation and find the answer. Okay. And then for the number 8, the rate law for the reaction 3A going to 2B is rate equals Ka with the rate constant per hour. What is the half-life of the reaction? Now, again you refer to the reaction table where we have the half-life. Now in this case, what we have here, we are given the rate constant. So from the rate constant units, you can find out whether this is a first order, second order or third order. So the rate constant units are per hour, or per second or per minute, they are the same. So this tells us this is a first order reaction. And then you refer to your table and see for a first order reaction, what is the half-life for a first order reaction. Okay, over here. So for a reaction half-life, T half for a first order reaction half-life is ln 2 over K. ln 2, you write ln and then put 2, that give you 0.693. So with that you can find out the rate constant or half-life. What is the half-life of the reaction? T half equals ln 2 over K. ln 2 is 0.693 and then the rate constant 0.0447. So you divide and it will give you the half-life. Okay. And then the next one, the rate law for the rearrangement of methyl isocyanide to methyl cyanide at 800 Kelvin is given 1300 per second. What is the half-life for this reaction? Okay. Now again, let's look at what is the order of this reaction. In order to use which half-life that we need to use, is it for the zero order, first order or the second order? You refer to the units. So the units 1300 per second. So what is the order of this reaction? If the units are per second, it's again first order. So for the first order reaction, what is the equation for the half-life? We just looked it up. T half is ln 2 over K. ln 2, you find it 0.693 and then the rate constant is given 1300. You put over here L into you find 0.693, so you can find out the half-life. Okay, you can get the answer for that. Number 10, the rate constant for the reaction given with the rate data 6 into 10 to the negative 3 liters per moles per minute. How long will it take the concentration of A to drop from 0.75 to 0.25? Excuse me. So it is asking about two different concentrations. If it involves two different concentrations, obviously we need to use the integrated rate law. Okay, we involve two different concentrations and the time, and from the units we can see whether it is going to be a first order, second order or third order. Liters, moles per minute. So you refer to your lectures. Okay, and then we can see the integrated rate law, and also we can refer to the units. Where's the slide? We had the units over here. Okay, so with these units tells us that it is a second order reaction. It was liters moles per second, right? It was this units, liters moles per second, so meaning it is a second order reaction. And then we refer to the second order reaction integrated rate law, which is this one over here, 1 over concentration of A at a certain time minus 1 over concentration of A at 0 equals kT. So we're going to use this one because it's a second order. Okay. Okay, so that would be 1 over AT minus 1 over A naught equals KT. All right. Okay, so concentration at a certain time 0.25 and initial 0.75. So 1 over 0.25 minus 1 over 0.75 equals rate constant is given as 6.00 times 10 to the negative 3 units liters moles per minute. So we're going to get our answer in minutes times t. So you can solve this one. 1 over 0.25 minus 1 over 0.75. You solve for that one and then equals 6 into 10 to the negative 3 times time. So you can find out the time, right? So this is mathematics, algebra. So you guys can do that part, correct? And this one is for number 10. Get the correct answer, and that's how you're going to solve it. Okay, and your answer will be in minute. That's for number 10. And for number 11, let's do number 11. Butadiene. I'm gonna erase this part over here. Butadiene, okay, reacts to C8H12 with the rate law of rate given with this information 0.014 liters moles per second. C4H6 raised to the power 2. So this tells us what is the order of this reaction if the reactants are raised to the power 2. So that tells us this is a second order reaction. Plus with the units, liters per moles per second, units are for a second order reaction. And it is asking what will be the concentration of C4H6 after 3 hours if the initial concentration is 0.025. So A naught is 0.025. We want to find out AT. And for the same thing, because it's a second order reaction, we use the same integrated rate law to solve this problem as well for the second order integrated rate law. So 1 over AT. So AT is what we want to find out. right? We don't know AT, so you're going to keep it as this. And initial concentration A naught 0.0, no, initial 0.05, 0.025 equals K, rate constant 0.014 times the time is 3 hours. Okay. Rate constant liters, moles per second, and then the time is given as 3 hours. So times 3 hours. Now you need to be vigilant here, because now this moles per second and hours. So you want to make sure you convert hours to seconds. Okay, how do you convert hours to second? 1 hour is 3600 seconds. So I'm going to go ahead and write it here. 1 hour 3600 seconds. Okay, so these seconds get cancelled. Hours to hours get cancelled. So you multiply 0.014 times 3 times 3600. These three together you're going to multiply. Okay, and then from this side you have this part to solve. 1 over 0.025, you find that answer, and you can solve for concentration of A. Okay, 0.014 times 3 hours times 3 times 3600, I think 151.2 from this side. Do this calculation and see if you also get the same thing. 151.2. So 1 over A T. So 1 over 0.025 is 40. So plus 40. 191.2. So then concentration of A going to be 1 over 191.4. So find the answer for this one. Okay. Yeah, that's for number 11. And for the number 12, the rate law for the reaction 3A to C. Rate is given liters per moles per hour, A raised to the order 2. Meaning this is also a second order reaction, right? Because the units are for second order, and also you can see 2 is right there, and these units also for the second order. So this is also a second order reaction. What is the half-life of the reaction if the initial concentration of A is 0.250? Now you need to refer to our PowerPoint slides to find out what is the half-life for a second order reaction. Half-life. So for a second order reaction, T half is inversely proportional to the initial concentration. So T half is 1 over Ka naught. So that's what you're going to be using. Okay. T half equals 1 over Ka naught. Right? So, rate is given like this. So this is the rate constant, 4.36 into 10 to the negative 2 times initial concentration 0.25 times 0.25, 1 over this one. So that would going to be your T half. Okay, yes, it would be in hours. 1 over 4.36 into 10 to the negative 2 times 0.25. Yes, so you guys can get the answer for that. And number 13, The decomposition of thionyl chloride is first order in thionyl chloride. If the half-life for the reaction is 4.1 hour, how long would it take for the concentration of thionyl chloride to drop from 0.36 to 0.045? It says it's a first order reaction already. Half-life is also given as 4.1. How long will it take for the number 13? So we are going to use the integrated rate law, but before that, since we are given the rate constant and we are not given the rate constant, but we are given the half-life. So we want to find out the rate constant first. So the T half is going to be ln2 over k. ln2 is 0.693 and then we're trying to find out k. So k is going to be then 0.693 over t half, which is 4.1. 693 over 4.1 is 0.169. 169 is the rate constant. And then you can use the integrated rate law for the first order reaction. That's going to be, I'm going to erase this one so I can use some space. Integrated rate law for a first order reaction ln A naught over AT equals KT. How long? So we are trying to find out T. So drop from 0.36 to 0.045. 0.3 ln 0.36 0.045 equals K we found from half-life 0.169 times T. So T is what you want to find out. So ln 0.36 over 0.045. So first you can solve for this part. 0.36 over 0.045, that is 8. So ln 8 would be 2.079. Excuse me. ln 8 equals 0.169 times t. ln 8 is 2.079 over 1.69 or 0.169. Okay, I need to check this. See if I am doing anything wrong. Please correct me. 0.693 over 4.1, 0.169. 2.079 over 0.169. Okay, good. I got an answer. 0.169 is the correct one, right? And now for number 13. Yeah, so we were doing this problem for number 13. Okay, number 13. Okay, so you will get an answer and you can write it down. Come on, 2.079. Okay, all right, and then number 14. Excuse me. The reaction methyl isocyanide going to methyl cyanide, first order with respect to methyl isocyanide. If it takes 10.3 minutes for exactly 1/4 of the initial amount of methyl isocyanide to react, what is the rate constant in units of per minute? Now, how do we answer this one? Okay, so let me go ahead and erase this part over here. What are the information given for us? this one, number 14, it says it's a first order reaction. Okay, it takes 10.3 minutes for exactly 1/4 of the initial amount of methyl isocyanide to react. If 1/4 has been reacted, how much left over? 3/4. So what is the rate constant in units of minutes? Okay, so we can use the integrated rate law. And yeah, so let's use the integrated rate law. ln A naught over AT equals KT, correct? Now it says 1/4 of the initial amount of methyl isocyanide to react. So then how much we have right now? If 1/4 has been reacted, we do have then right now 3/4 left from the initial amount, meaning 3/4 of A naught remaining equals K. Rate constant is what we want to find out, and then the time is 10.3. Okay, so ln A naught get cancelled, and ln 1 over 3/4 is, if you do find that, that would be 1.33. Excuse me. ln 1.33 would be K times 10.3. So you can find out what is ln 1.33, and you divide it by 10.3 to find the answer. Okay. ln 1.33 is 0.2876 over 10.3 would be the rate constant. So you guys can find out the answer. Again, I'm telling you, do check these ln values if I'm getting the correct numbers. If not, please email me so I can correct it for the whole class. That's for the number 14, right? And then let's look at number 15. A first order reaction has a half-life of 20 minutes. Starting with 1 into 10 to the 20 molecules of reactant at time t0, how many molecules remain unreacted after 100 minutes? And a first order reaction. So it's a first order reaction. So what are we going to do is we're going to use the half-life given. So from that we can find out the rate constant. And then we can see how many molecules remain unreacted. Okay. So how do we find out the rate constant? So T half, since the half-life is given, T half equals ln 2 over K. So K would be ln 2 is 0.693 over 20. So the rate constant is going to be 0.03465. Okay, and then the integrated rate law, ln A naught over AT equals KT. Okay, starting with 1.00 into 10 to the 20 ln over AT equals K 0.0346 times 100 minutes. 100 minutes. So you guys can find concentration of this one by solving this equation. Okay. So first multiply these two and get the anti-log. So 1.00 into 10 to the 20 over 80 would be E 3.465. Find the exponent 3.465 anti-ln 3.465, and then find what is the AT going to be. And if it falls to any of these answers, you have the answer, but whatever the answer you get is not going to be one of these choices, then it's going to be none of these choices. Okay, that is for 15. 826. Okay, number 16. Carbon-14 is radioactive isotope which decays with a half-life of 5,730 years. What is the first order rate constant for its decay in units of years? Again, you can use the half-life. It's easy, straightforward. You just have to write the T half equals ln2 over k. Rate constant k would be ln2 over T half, which is 5,730. ln2 is 0.693. You divide by 5,730. Okay, that would give you the answer. That's 16. Yeah, that's correct. I will stop here.